There's only one country that has quantum computing supremacy, and it's not China. And I know that makes some people mad because they like to look at this chart of public funding for quantum computing technology, and they see China on top, $15.3 billion. And the US, where are we? We're 3.7. That's because the United States puts a lot more private money into it, like Google, Microsoft, IBM. Let's look at total, private and public, as a percentage of GDP. Finland is at 7%. Finland has a GDP of $300 billion, so about the size of the state of Connecticut. So 7% of that is about $21 billion. The US in total is 0.62% of its GDP spent on quantum computing research. Our GDP is 27.9 trillion, so their total spending is about $170 billion annually. So let's just look at the top 10 list of quantum computers on the planet. And look, the first two are from the US. Number 3, Xanadu, is actually from Canada. In fact, out of the top 10 quantum computers, China is in number 4, but that's it. Now, don't get me wrong, China does have a lot of advantages. They are also coming a long way, and they have the second highest number of scientists that are currently cited, with 23,000 out of the top 100,000 on the planet. But the US is still the clear winner, with 69,258 scientists out of the top 100,000 that are most commonly cited. And in 2022, over 600 of the top 1,000 scientists on the planet were in the United States, while China had maybe 10 or 15. The US has a lot of problems, but ever since the end of World War II, we have been the #1 importer of the best scientists on the planet. Everybody wants to leave their country to work here, including Chinese scientists. While China does produce a lot of brilliant people, it is much harder to work and innovate under such a controlled and authoritarian regime than a much more open scientific community. But what even is quantum computing? Let's talk about that for a little bit. The main difference between a quantum computer and a regular computer is that a quantum computer operates by qubits, while a regular computer just goes by bits. A bit in a regular computer operates in only 2 directions, 0 or 1. You could call that yes or no. It's binary. But with a qubit, you can have an infinite amount of directions that may be possible to round in 1, but there's still infinite possibilities, which is why it's called quantum. With original computers, we are working with gigabytes, terabytes, even larger numbers. But theoretically, with qubits, you need only 50 or 60 of them to replace the most powerful supercomputer that we currently have. And right now, Google's newest released, most cutting-edge quantum computer, Willow, is so advanced it may prove the existence of parallel universes. Willow solved a mathematical equation in under 5 minutes that would have taken a regular supercomputer 10 septillion years. That is 24 zeros, so it's bigger than billion, trillion, all that put together. The crazy thing is, Willow is capable of doing this with only 105 qubits. A lot of people assume that the more qubits you have in your quantum computer, then the more computational capacity it has, and that's not true. Canada's D-Wave has 7,440 qubits, and there's something called Atom, which has 1,180. But look at IBM Condor. They have less qubits, but they are considered the #1 quantum computer. And it looks like Google's Willow is even better than IBM's #1 Condor, with 1/10 of the amount of qubits. The problem with having too many qubits is the more qubits you have, the more room for error there is. Just like a regular computer's bit is an abstract unit of information, so is a qubit. It's just an abstract of quantum information. So they're mirroring quantum behavior, which means they have to be kept in settings that are undisturbable. That's why quantum computers are some of the coldest places in the known universe. They're kept in these cold spaces to make sure that no other form of energy disturbs how they vibrate or spin. And also, these cold conditions prevent the qubits from interfering with the other qubits. And the less qubits you have, the less of this interference we have to worry about. Which is why what Google has done is such a big deal, and no other country or even company has anything close to it for now. For those of you worried about quantum computing being able to break every password or hack into every other cryptocurrency, I'll just say that quantum computing isn't there yet. Leading quantum physicists and scientists are even saying the same thing, that we are maybe decades away from that kind of possibility. Because right now, even Google's most advanced Willow would take, I don't know, thousands of years, maybe even longer, to break Bitcoin's current form of cryptography. And I'll leave you with this thought. A lot of people are just afraid of quantum computing overall because it is changing the world, yet we have had incredible cutting-edge inventions over the past 500 years. And has the world become a worse place? I don't think so. I am the Geo Husar, and the only reason why you're hearing all this fear bait about quantum computing is because there are experts and just regular people who want those clicks and they want to be relevant. Because how much sensationalism does quantum computing being a good thing happen to generate? Not much. Thanks for watching.